Hello viewers, welcome to my channel Maths with VTC. Today we are going to see pair of linear equations in two variables, that chapter. A linear equation in two variables represents a straight line in xy plane, that is Cartesian plane. A pair of linear equations in two variables will represent a pair of straight lines in Cartesian plane. So, what are the possibilities of a pair of straight lines in a Cartesian plane? They can be like this. They are parallel. So they can be parallel, or they can be like this. One line lies on the another line. This is called coincident. So these two lines are coincident. This is another situation. These two lines intersect at a single point. So there are three possibilities. Only there are three possibilities. Either they can be parallel, or they can be coincident, or they can intersect at a single point. So these are very interesting situations. Using these three facts, we are going to solve pair of linear equations in two variables easily. Consider this situation. Akhila went to a fair in her village. She wanted to enjoy rides on the giant wheel and play hoopla, the game in which you throw a ring on the items kept in a stall, and if the ring covers any object completely, you get it. The object may be either 100 rupees, or a soap box, or a toy, something like that. So you have to throw the ring on the particular object and it must cover the object. Then you will be given that object. So that is the game called hoopla. Okay, let us not go into detail that. Now, consider this situation. The number of times she played hoopla is half the number of rides she had on the giant wheel. If each ride costs rupees 3 and a game of hoopla costs rupees 4, how would you find out the number of rides she had and how many times she had played hoopla provided she spent rupees 20? Now we are not interested in the solution of this problem. What we are going to do is we have to construct a mathematical model representing this situation. When you construct a mathematical model, to your surprise, it will be a pair of linear equations. So that is the underlying fact. So we have to construct a model for this. So here what is to be found? The number of times she played giant wheel and the number of times she played hoopla. So in mathematics what we do, if something is unknown, we assume that as x or y or z, something like that. So here you take x be the number of times she played giant wheel and y be the number of times she played hoopla. Now you can construct a pair of linear equations like this. Y is equal to half x because number of times she played hoopla is equal to half of the number of times she played giant wheel. Therefore, y is equal to half x. Now giant wheel costs rupees 3 while hoopla costs rupees 4. Therefore, 3x plus 4y is equal to 20, the amount she spent. So you get two equations. Both are linear, a pair of linear equations. These equations mathematically represent the situation. Now let us see linear equations in two variables. The general form is a1x plus b1i plus c1 is equal to 0, a2x plus b2y plus c2 equal to 0, where a1, b1, c1 and a2, b2, c2 are constants, xi are the variables. A pair of values m, n is said to be a solution for the above two equations if a1m plus b1n plus c1 equal to 0 and a2m plus b2n plus c2 equal to 0. You have to replace x by the value m and you have to replace y by the value n. Then the equation must be satisfied. You have to get 0 in both equations. In that case, we say m, n is the pair m, n is a solution for the pair of linear equations. Now let us see some definitions. A pair of linear equations in two variables which has a solution is called a consistent pair of linear equations. A pair of linear equations which has no solution is called an inconsistent pair of linear equations. So consistency means existence of solution. Inconsistency means non-existence of solution. A pair of linear equations which are equivalent has infinitely many distinct common solutions. As I said, if a straight line lies on another straight line completely, then all the points are common. Then all the points are solution of that pair of linear equations. Such a pair is called a dependent pair of linear equations in two variables. So note that a dependent pair of linear equations is always consistent because it has infinitely many solutions. We can now summarize the behavior of lines representing a pair of linear equations in two variables and the existence of solutions as follows. The lines may intersect in a single point. In this case, the pair of equations has a unique solution, consistent pair of equations. The lines may be parallel. In this case, the equations have no solution because they don't intersect, no common point. They are parallel. Therefore, they are inconsistent. This you have to remember. Third, the lines may be coincident. In this case, the equations have infinitely many solutions. Method to find the consistency of pair of linear equations. Let us consider the following three pairs of linear equations. The first pair, x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0. If you draw straight lines for these two, we will get intersecting lines. Next, second problem, 2x plus 3y minus 9 equal to 0 and 4x plus 6y minus 18 equal to 0. So the lines coincide. If you observe the equations, you will realize that the second equation is obtained simply multiplying the first equation by 2. Therefore, both are same. That means the lines coincide. Therefore, they are coincidental lines. Next, x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. The lines are parallel. The lines are parallel. So how to find the consistency? Now you look at this table. So x minus 2y equal to 0, 3x plus 4y minus 20 equal to 0. This is the first pair. So a1 by a2, b1 by b2, c1 by c2. You form all the three ratios. 1 by 3, minus 2 by 4, 0 by minus 20. Compare the first two ratios, a1 by a2 and b1 by b2. a1 by a2 not equal to b1 by b2, then you need not bother about c1 by c2. Immediately you can say they are intersecting lines and have exactly one solution. Next, 2x plus 3y minus 9 equal to 0, 4x plus 6y minus 18 equal to 0. Form all the three ratios, 2 by 4, 3 by 6, minus 9 by minus 18. a1 by a2 which is equal to b1 by b2 which is equal to c1 by c2. So, in this case, what we conclude is they are coincident lines. Therefore, they have infinitely many solutions. Third problem. X plus 2y minus 4 equal to 0, 2x plus 4y minus 12 is equal to 0. You form all the three ratios. You find that a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. So in this case, what we conclude is they are parallel lines and they don't have solution at all. So this table is very, very important. You have to remember these properties of the ratios. When a1 by a2 not equal to b1 by b2, you can conclude that they are intersecting lines and they have unique solution. When all the ratios are equal, you can conclude that the lines are coincident and they have infinitely many solutions. When a1 by a2 is equal to b1 by b2, but they are not equal to c1 by c2, that means they are parallel lines. Parallel lines means that they don't have solution at all. So these things you have to remember. It is very simple to remember also. So here intersecting lines, unique solution at the point of intersection, coincident lines, infinitely many solution, parallel lines, no solution at all because there is no common point. Example 1. Check graphically whether the pair of equations x plus 3y equal to 6 and 2x minus 3y is equal to 12 is consistent. If so, solve them graphically. So what I am going to do is x plus 3y equal to 6 is a straight line. To draw a straight line, I need at least 2 points. So I find 2 points on the line and draw the line x plus 3y equal to 6. Similarly, I find 2 points on the line 2x minus 3y is equal to 12 and draw the line. Then I will check whether they are consistent or inconsistent. First line. X plus 3y is equal to 6. Therefore, y is equal to 6 minus x divided by 3. So, when x is equal to 0, y becomes 2. When x is equal to 6, y equal to 0. So, just 2 points enough to draw this straight line. Similarly, in the second equation, y is equal to 2x minus 12 divided by 3. So, when x is equal to 0, you get y is equal to minus 4, and when x is equal to 3, you get y is equal to minus 2. So, I plot these points on xy plane and I draw the lines. So, here 0, 2, 2 that is represented by A, 6, 0 that is represented by B. So, joining these 2 points, you can draw a straight line. Similarly, 0, minus 4 that is represented as P, and 3, 2 that is represented as Q, this point. So, joining these 2 points, you can draw the straight line. Obviously, you can see that these 2 straight lines intersect at the point 6, 0, B. That point is denoted by B, 6, 0. Therefore, what we conclude? The given pair of equations is consistent and it has a unique solution. X is equal to 6 and y equal to 0. Example 2. Graphically find whether the following pair of equations has no solution, unique solution, or infinitely many solutions. 5x minus 8y plus 1 equal to 0. 3x minus 24 by 5y plus 3 by 5 is equal to 0. So, 2 equations are given. As in the previous problem, I am going to proceed. But you look at the second problem. The coefficients have fractions. Here minus 24 by 5 plus 3 by 5. So, in order to avoid these fractions, I want to multiply the second equation, left hand side and right hand side, by 5 by 3. If I multiply the second equation both sides by 5 by 3, I get 5x minus 8y plus 1 is equal to 0. To my surprise, it is same as the first equation. 5x minus 8y plus 1 is equal to 0 is the first equation. When the second equation is multiplied by 5 by 3, it also becomes 5x minus 8y plus 1 equal to 0. It indicates what? The lines are coincident. One line completely lies on the other. Therefore, the pair of linear equations is consistent and has infinitely many solutions. Consider example 3. Champa went to a sale to purchase some pants and skirts. When her friends asked her how many of each she had bought, she answered, the number of skirts is 2 less than twice the number of pants purchased. Also, the number of skirts is 4 less than 4 times the number of pants purchased. Help her friends to find how many pants and skirts Champa bought. So here we are not given linear equations directly, we have to find it. Here we have to find the number of pants and the number of skirts she bought. So they are unknown. So what we do is we assume x be the number of pants she purchased and y be the number of skirts she purchased. You look at this line. The number of skirts is 2 less than twice the number of pants purchased. Number of skirts is equal to y. So when you construct an equation, it will be like this. Y is equal to 2x minus 2 because it is 2 less than twice the number of pants purchased. Therefore, it is 2x minus 2. Also, it is 4 less than 4 times the number of pants purchased. Therefore, y is also equal to 4x minus 4. Now, let us draw the graphs of equations 1 and 2 by finding 2 solutions for each of the equations. When x is equal to 2, y is equal to 2. When x is equal to 0, y is equal to minus 2 here. Similarly, for the second equation, y is equal to 4x minus 4. Therefore, when x is equal to 0, y is equal to minus 4. When x equal to 1, y is equal to 0. When you draw the graph, you get these two lines and they intersect at 1, 0. Therefore, x is equal to 1 and y equal to 0 is the required solution. That means what? The number of pants he purchased is 1 and the number of skirts he purchased is 0. Let us verify it. 2 into 1 minus 2 is equal to 0. 4 into 1 minus 4 is also equal to 0. Thank you viewers for watching my video.